Why? Because they're having a complete data. The other record, either they're having one data at a time that's not available. So, for example, if they measure week 1, week 2, week 3, one of these weeks may be not available in the record. So now the whole case will be dropped from the analysis. So now we end up with only 33 cases out of 133. And as you can see, this may affect the result, this may affect the conclusion if you're trying to use MANOVA, or even if you're trying to use ANOVA. So now, mixed effect regression, it can overcome this issue. It still can utilize your data with a missing, and it can model it, okay? So it is just extend the modeling in repeated measures ANOVA and MANOVA, and also can allows for unequal variance covariance structures as well, and also could analyze balanced and unbalanced design. So the mixed model, it is statistical model that describes the relationship between a response variable and the covariates. These covariates can be treatment, can be age, can be gender, and these will be measured along with the response. So similarly to the example of lead levels, we can use the same example of lead. We still can use the mixed effect to model it. Air pollution example as well. I can go back and bring you that example so you can see. Yes.
What do you mean by balanced and unbalanced?
Balance, that you have equal numbers in each group. So for ANOVA, for example, you have treatment A, treatment B, treatment C. So you have 20, 20, 20. This is balanced. But now if you have 15, 20, and 25, this is unbalanced, right? So mixed effect, it could also analyze this kind of data as unbalanced. So ANOVA assumes that you have a balance. You have equal number, equal size of groups. MANOVA as well, you assume that there is equal numbers. So for the mixed effect models, it handles missing data, it handles correlated data, it handles unequal variance covariance structures. So all this is what we are being faced challenge in a repeated measures ANOVA, a repeated measures MANOVA. So now we have a solution for this using a mixed effect regressions that will handle our correlated data, will handle the unequal variance, and also will handle the missing data. So it is very important in mixed model that at least one variable must be subject. So now subject, it will be considered as a variable. Before, we never talked about subject. We just saying subject must be there in the data, but we didn't control for it in the analysis. Remember in the coding, we never included the subject ID. So now in mixed model, we will be including the subject as a variable in the analysis, and we're going to control for it. So it's going to be a subject ID or MRN, anything, a unique identifier for a patient that I'm going to use in the coding. So I'm going to use something called prac mix. In this prac mix, there is a variable which is subject ID or MRN or any unique identifier must be used. So in SAS, there is a keyword called subject that identify and asking for this subject ID. So if you name it ID, then give it. If you name it MRNs, then give it. If you name it anything unique identifier, just give it to SAS, will understand it. Now we just mentioned that the mixed model, which is statistical models that incorporate here now, what this is new for you, incorporate both the fixed effect parameters and the random effects parameters. So the statistic class that you have taken till last week, we are modeling only this part. Fixed effect. From principle by statistic through the statistical model in epidemiology, through part of this advanced by statistic, we've been working with all the variables that is a fixed effect. What that means, fixed effect, we'll define it later, but the fixed effect that any variable that can be controlled by the researcher. Any variables that can be controlled by a researcher. Researcher may decide, say, well, I'm going to study patients, adult patient. So this patient chosen by what? The researcher, right? So now researcher define the age group. So now age is a fixed factor. Researcher may say, I'm going to include only children, right? So now age of children here is a fixed, because determined by who? By the researcher. So the fixed effect parameters, it is any variables that defined by the researcher. Gender, for example. Researcher may say, well, I'm going to study only female. It's chosen by a researcher, right? So now gender is a fixed.
So the including criteria?
Yeah, likely it will be in the inclusion criteria or maybe not in the inclusion criteria. It is just a variable characteristic of the patient. Or researcher may say, I'm going to study only males. Or researcher may say, I'm going to study both, male and female. So still the gender is a fix. Why is fixed? Because chosen by the researcher. Because he got an option, either to study males only, or to study females only, or to study both. Right? So it is a fix. You see the example of fixed effect parameter? It is just a variable that determined by the researcher. Okay? And now, what is new for you now? We've been analyzing gender, we've been analyzing what? All the variables you think of. We studied before. All it is a fixed effect. Now, what is new for you now? This here, the random effect. Now, the word mixed. What is the word mixed? It is a combination of two effects, the fixed effect and the random effect. So the fixed effect we already know, correct? Now what is new is the random effect. And these two bring up what? Mixed effect. So now, what is the random effect? The random effect, which is looking at the variables that comes from the sampling. So for example, if I say, I'm going to sample up patients from National Guard Hospital, right? So now patients, they will be random. The subject themselves, they will be random effect. Because if I'm going to repeat the study again, I'm trying to replicate the result of my study. If I'm going to repeat it after 1 year, what do you think? Do you think you're going to select the same patient or a different patient, maybe? Right? If you don't have ID, if you don't include any ID, right? If you want to replicate the study again, likely you're going to choose a different patient. So now this patient are random. Okay, another example, center. If I'm trying to study three center in Riyadh, hospital center, how many center we have? Many, right? And randomly select 3. After 2 years, I want to repeat the study again. So I have to again randomly select 3 center.
We exclude the previous one.
Not excluding, still because randomly. But do you think the chance of reselecting these 3 center again? How many center you have in Riyadh? How many hospitals? 100, 200, 500. So what the chance that you're going to select exactly the same 3 centers? Right? Minimal, right? So this is why center, you're going to treat center as a random. Another example, school. How many schools we have? Thousands, right? So now, if I'm randomly selected 5 schools I want to study, 1 from each region of Riyadh. So I'm trying to repeat the study again. So randomly, out of these thousands, I'm going to randomly select another 5, so I can replicate my study. Now, what the chance that you're going to select the 5 school again? Minimal, right? So this is why you have to treat school as random. See that? So yes.
الشانس انه كان نفس السكول او نفس المركز بس هذا بدزم يعني على سامبل تكنيك or
It is just randomly. You're gonna pick out of this 1,000 center, you're going to pick 5 randomly, and then you study them. Yeah, it is random. So this is a random effect. So now the difference between the fixed effect and the random effect is what?
Controlled by this research.
The fixed effect, the researcher involved and decide what category he wants to choose, right? The random effect, it's something to do with the sampling, the selection of the subject for your study. Subject are random, right? So this is always, it comes when you're trying to replicate your finding from previous studies. Likely you need to consider that as a random. So now the variations in the response could be associated with the random effect terms, such as subject, school, center, clinics, etc. So anytime that you're considering doing a study on centers, different clinics, you're trying to do a subject, but you observe them over time, you need to make sure that you have to use what is called mixed effect models. So this is going to add for you, and it's going to, there's these variations, there's amount of variation we say explained variation, there is another amount of variation we say unexplained. So remember the unexplained variations, which is what? The error, right? I always wanted to reduce the error. So reducing the error must be done through adding these random effects. So adding these might improve the explained variations and reduce the unexplained variations. So why we are considering these? Why are we considering school, for example? Why are we adding school to our model? Remember, if I selected 5 schools from Riyadh, 1 north, 1 south, 1 east, 1 west, 1 center. Free sample? Yes, this is possible, but there is one more important than this. Cover all area. One more important. Reduce bias. Now, what do you think about the students being from the east? Are they correlated? They're supposed to be correlated, right? In terms of their economic status, in terms of their behavior, in terms of. So they will be what? They will be correlated, right? And similar from the south, similar to from the north, similar to the west, similar to the center. Likely they will be sharing the same characteristic, their behavior. They are from one school, so likely they will be correlated, correct? Same thing for clinic or center. Clinics. National Guard center compared to a center that maybe Prince Muhammad, right? And maybe Khasusi, right? Yeah. this in different region, different area. Do you think the same patients comes to the National Guard, they are similar in characteristic or in behavior or anything similarly to King Saud Medical City?
No.
Yeah.
No.
Do you think they will be
No.
similar?
No. No.
They should be this. Yeah, they should be this. There's some
similarity, but
between patients within single center. There will be what?
Similar between.
Correlated,
Just different.
but also there is between centers.
Between something not correlated.
Likely will be not correlated, right? So now what this treating is considering the correlation between or within the center.
It's fine.
See that? So what the random effect is also controlling for the correlation within the school because they look similar in their characteristic. So we're going to consider that they correlated because they come from the same school. But now if a school comes from the north or the east also, they're going to be correlated within the school. See that? So the random effect, it has very important to reduce the amount of error that can be produced in the fixed effect model that we have done.
Doctor, the unexplained variation, the same meaning of error?
It is the error, the epsilon, remember? Yeah.
Unexplained variation.
Unexplained.
To explain.
They explained the part that explained by the model, the part that you produce from data spaces. Yeah.
يعني دكتور random effect use it to reduce within and between. يعني
The random effect, yes, it's used to control for the correlations within the unit, which is, I can call it the school or center, and also between. If there is something exists, also it will be measures. So now it is important to add this term. You see how important? Now you mentioned something important. You say, you know, bias, right? You mentioned that it must be a multi-center. Yes, multi-center always is a good thing to do, but you need to control for more than that because this is a within unit correlations. You need to control for this. So by adding this term as a random effect, you can reduce the amount of error unexplained or the unexplained variations, which is this would increase the accuracy of your estimate of your models. Okay. Now we already studied that there's two
fixed
type of
and
factors we have. We can call them
fixed
one a
and
fixed factor, the other one random effect factor. You can call it fixed factor, random factor. So to explain each one, now what does a fixed factor mean? The factor level were set by at the fixed level or defined by the researcher. I think it's clear, right? This is a fixed effect factor, which is can be defined by the researcher. I give example of age. It is a fixed. Why? Because researcher decided to study only adult, or researcher decided to study children, or researcher say I'm going to study elderly. So this is a fixed.